Episode 9 of Overview Biostatistics will consider the p-value and the confidence interval simultaneously using another example. So let's make the sample like a study with the dichotomous outcome about cured or not cured. Compare the cure rate between drug A and drug B. A, I put it as alternative treatment proposed to be used in the place of drug B. And drug B base, conventional treatment. So we want to compare the efficacy of the two drugs so that we can make decisions that drug A can be used in the place of drug B or not. Go ahead with conducting a clinical trial with the sample size of 50 per arm, drug A and drug B. So at the end, we get the main statistic to answer the research question about the probability of drug A, the probability of cure or the cure rate. Cure rate of drug A is 80% and drug B is 50%. So we take a rate difference here, or the risk difference here is 30%. And this is a calculations for the confidence interval to get 26% to 34% and the p-value of this. So everything the same as the previous episode about how to calculate for this. The change is about how the standard error is calculated. That means if we understand this, we can apply to any. Now to get in touch about the p-value and the confidence interval, how it's correlated, we make this diagram that if there is no difference between the two drugs, it is 0 here. If the difference is positive and mean drug A cure more than drug B, is in this direction, and another opposite in another. And the dotted line here is the meaningful level, because in clinical research we really need to have a meaningful level that, for example, here in these situations we will recommend to use drug A in the place of drug B if the lower limit of the confidence interval did not touch this line, whatever, let's say 25. Okay, so the 26 of lower limit here will be this, and this is 34, and this one is the estimate from the sample, the statistics from the sample. Okay, so here I adopted from the Armitage and Burry, this book. You can find it. 8 scenario. The first 4 scenario here, A, B, C, and D, the confidence interval did not touch the no difference, which is 0. So the confidence interval that is not cover the null value is also means significance as well. That means the p-value is less than 0.05. Just take a look at the CI, we know the p-value that less than 0.05 if it's not touch or cross the null value or significance. And the remaining 4 scenario means p-value is greater than 0.05 because the confidence interval cross the null value. Okay. So let's take a look first at the first 4. What is different even if all 4 scenario, all 4 studies are significant, p-value of less than 0.05. In this scenario, that means the conclusions is okay to say recommend to use drug A in the place of drug B because at worst the drug A is about 26% greater cure rate than drug B, right? From our example here, okay? But it will be more confidence if the scenario is like that. Means that a greater efficacy if it's like B scenario. This is more confidence. But it will be inconclusive in scenario C because it could be not, even drug A is greater than drug B, it could be not beyond 25% meaningful level. Okay, I just make it up that why 25? It could be like drug A is more expensive. They will not change if it's not beyond 25% more cure rate, for example. Okay, so that means if like this, it's inconclusive. But tendency is prefer to drug A, but still we will not recommend. Say something like may have more efficacy, just like that. But in scenario D, it's totally opposite. That means even if it's significant, even if that A is better, but it's not, even the upper limit is not beyond 25. So even significance, even is better, but not clinically better. Statistically better, but clinically, biologically, sociologically, whatever, is not meaningful. So this one recommend to be no, not recommend to use drug A. You know, it could be like more expensive, but the benefit is not. Okay. In this 4 scenarios, there are no significance. In scenario E, it's tend to be, drug A tend to be better than drug B, but it could be also worse. You know, but the tendency is prefer to drug A, right? So the conclusion remain inconclusive, but you know, it could say something like, however, drug A may have a high efficacy, but this study have low power with a wide confidence interval. Larger study is warranted, for example. So it generates a new research question. But it is not in scenario F. There is no tendency at all, or uninformative totally. Compared to scenario G. Scenario G, under a research question about A can be used in the place of B or not. Scenario G, even it's non-significant, it's answered the research question already that no, drug A is not the choice. No more new further research is needed. Stop, something like that. Conclusive, you know, in terms of the question, research question, even if it's no significance. So this scenario is just like non-inferiority trial. Okay, we are not looking at p-value. We're looking at the upper or lower limit according to, depend on what we try to demonstrate or research question. And we just consider the lower or upper limit for the key interpretations compared to non-inferiority margin. Okay. Now, the last scenario, if we change the same thing, if we remain consider Aristo's question about duck A can replace of duck B or not, the last scenario will say no and stop, right? But if I change the Aristo's question to be these two drugs is the same efficacy or not, that means to demonstrate equivalence, we look at the narrow confidence interval that if it's lie between the equivalence margin, only these situations where we can interpret the results that the two groups comparison is the same or equivalence. In this case, we do not look at the p-value of non-significance to say equivalence, but the confidence interval that narrow enough or small enough close to the null value. And we need to have that it will not touch the equivalence margin. Only that situations we can interpret about no difference, no associations, or equal. Not look at p-value, but look at the magnitude. Okay, so this is, we look at it, the p-value and the confidence interval simultaneously. If you, up to now, completely lost from all my talk, I suggest you to start over again. And still, this is the safe tips back home. First, in your research, always report the evidence to support your conclusions with the 95% confidence interval in the results section. You can put p-value, it's optional, but do not report solely p-value and say significance. It's highly misleading. It's not fair to the audience. Second, always reinterpret the results or conclude the results based on the magnitude of the effects, either the lower or the upper limit of the confidence interval compared to the meaningful level, which is judgment of the community. Interpret based on that. P-value says something like significant or not significant. It's optional. You know, you can decorate your conclusions by saying significant, you know, just to communicate with some group of people, but don't mislead them. Never interpret p-value of greater than 0.05 or non-significance as if it is an indication of no difference, no associations, or equal. No, never. We can interpret like that only when the CI or the confidence interval is very small, you know, not that difference is not meaningful, it's very small. That association measure is very small or not meaningful. In that case only we can say no association, no difference. That's my safe tips.